I just want to talk a little bit about geological and hydrogeological investigations for geothermal projects, particularly in Manitoba, and some of the things that we've noticed in the last, I guess, probably 60 years that we've been involved in these projects. Just a little overview of the things that we're going to talk about. It should take about 40 to 45 minutes. Hopefully, I get close to that. So. I'll talk a little bit about the geology of Manitoba and the hydrogeology of Manitoba, in particular the major aquifers that we have here. We have bedrock aquifers. We also have aquifers in the overburden. We have saline and freshwater boundaries that are naturally occurring and are fairly prevalent in what's going on here. We also have significant areas in Manitoba where conditions are flowing and that water levels in the aquifers are above grade. I'll get back into sort of the reason why we're all here, I guess, is to discuss some of these things in relation to when people try to do geothermal. Some of these basic geology and hydrogeology things that we take for granted often can cause problems for us. Transmissivity issues in the bedrock, which I'll get into further. Issues of aquifer contamination, and again, we'll expand on that quite a bit later. Interconnection of aquifer units, encountering flowing conditions, recirculation on open water well systems, which is an ongoing issue. Pumps, pitless units, connections to the water wells, these types of things, operations and maintenance and regulatory concerns, and just some final recommendations. So I'll just talk a little bit about the bedrock and the Quaternary geology that we have here. We'll try and keep this, say, fairly brief. Some people will probably know a lot of this stuff. But this is a cross-section, basically just sort of following along the U.S. border here. Manitoba lies, I guess, in a big, huge bowl of sediments. The western Canadian provinces of Saskatchewan, Manitoba, and Alberta kind of form that basis of sedimentary rock. So the pink rock we tend to see there in the bottom in this figure here is the Precambrian rock that pokes out in the eastern part of the province. And then all those multicolored layers there are different layers of limestones and shales and sandstones and things like that have been laid down there, and then the basins were tilted. Here's another cross section through it. You can see with the different sort of slopes of those cross sections that things were laid down in different places, and then we had some basin tilting that occurred, and then we laid things down in a different sort of a manner. The geology in the bottom part, lying most close to the pink Precambrian, tends to be more of the carbonate rocks or the limestone rocks that we tend to see a lot of, people are familiar with. The rocks lying further to the west of Manitoba, the Swan River Formation, those things tend to be more based in shales. So again, all of this has been eroded away and it's been covered over by a fairly thick deposit of glacial deposits that came in a couple different sets. So if we strip off the overburden in Manitoba, we see what we would refer to as the subcrop. This is a little bit of a grainy image here of the bedrock geology if we were to just take off all of the overburden cover, so all of the unconsolidated stuff, clays and silts, sands and gravels and things. And this is the way the bedrock would be laid down. So the formations in sort of the southwestern part of the province, typically those sedimentary basins. The rest of it is Precambrian up to the north. Then we have a further sedimentary basin that kind of lies in the Hudson Bay area. It's not as commonly drilled, but it is still present. We take the figure on the right of my screen there. It tends to show the quaternary or the superficial geology that we have. The superficial geology is more of the geology that we tend to see fairly close to the surface. So clays and silts and things like that. And we can see down in the bottom part of the south part of Lake Winnipeg, we can see that little black dot there is Winnipeg, and that's sort of the Red River Valley, which is a pretty broad, post-glacial lake, lacustrine type clays we tend to see there. So basically, Manitoba geology it's pretty complicated in a lot of ways. So just going through the individual formations, most people are familiar with we'll talk kind of the above the Precambrian for the most part. The Precambrian is that fairly, old rock. In fact, it's our oldest rocks in Manitoba. but lying on top of that is a layer of sandstone that we know locally as the Winnipeg Formation. The Winnipeg Formation is primarily is a sandstone unit, but it does have a lot of portions of shale as well, and it forms the base of our unit. We tend to call it the basal clastic unit, but it's formed mostly of a very, very uniform grade of a very, very pure and very clean, not a lot of impurities and things in it, of straight silica. It's quite a nice formation. It's very hard to see though. You can't really see it because it doesn't tend to come out too often. There's only two places in Manitoba where you can actually go and visit the Winnipeg Formation and walk in it. The first one is on the far eastern shores of Hecla Island. There's a little bit of an outcrop of the Winnipeg Formation there. And the only other place that we see it is the Black Island in the middle of Lake Winnipeg, just off the shore of Hecla Island. And there's a significant exposure of Winnipeg Formation there. The geology and the hydrogeology of it is fairly interesting. This is a map that was produced by the province probably 40 or so years ago. It sort of shows the groundwater flow direction, and basically things are from the central part of the basin. There's pressures that push upwards and flow sort of more towards the east. So the flow is basically from the west to the east, and the arrows kind of indicate where we think it's flowing. This formation, though, in and around the Brandon area, be thousands of feet deep. So it's difficult to get a lot of great information on the aquifer in that area. The most part that we know about the Winnipeg Formation is the area that lies east of the Red River to where the formation cuts off. That's kind of straight east of Steinbach. That tends to be the area where it's receiving freshwater recharge. So it's the area that we tend to know better. Lake Winnipeg does act as a point of discharge for it, so there is leakage into the bottom of the into the lake from this formation, and it's a fairly complicated formation. It's not a lot known about it because it doesn't get mentioned too often. Here's some shots of the Winnipeg Formation that were taken. A bunch of people from the province and myself a number of years ago. We went up to the Black Island to see the formation. And this is the case where they used to mine it for silica sand. They probably mined it for about 50 years, and this is the remains of the quarry that was there. So there's a couple shots there of the formation. It's a very interesting formation. The interesting thing with the water quality, though, in the Winnipeg Formation is pretty much if you look at that area in the Winnipeg area where, to see if my cursor works here, but in this area right here, pretty much in that 1 grams per liter there, that's kind of the area where it's fresh, is this portion here. And then there's a tiny little wedge of it up towards near the just south of Gull Lake in that area, just kind of around the where Scantlebury is. We tend to see it being fresh there. The rest of the Winnipeg Formation is not really well looked at all because, again, it gets very deep very quickly, and the water that's in it is very old. So that water would be probably 10,000 plus years old, whereas the water that's in the freshwater portion of it is quite recent, less than probably a few hundred years old. The older water, say that's 10,000 years old, that's very, very brackish. And towards the deeper parts of the basin, the Winnipeg Formation can be several times seawater. So it's quite a fairly pronounced change. The boundary that we see in the water quality is not a hard and fast boundary. In this, it tends to change, whereas the sodiums and the chloride levels tend to shoot up quite a bit over maybe a mile or two, and then all of a sudden it's keep going further west, it gets much worse. So the current interface for this is kind of sort of near the Red River. It's not really right on top of it, but it's near it. It's certainly not controlled by it. So the one thing that's very interesting about the formation, there is a protecting layer over top of it, which tends to isolate it from the formations that are above it. and that's a fairly thin layer of shale. And that shale prevents a lot of fluid movement between the lower formation into the upper formations that are on top of it. The one thing, it's also a fairly uniform, the conductivities of it, it's fairly uniform. The wells that you can put into it are fairly repeatable, fairly high yields, and it's fairly well used for municipal water supply in the area where it's fresh. So lying on top of the Winnipeg Formation, and the thing that's kind of isolating from it in places, this is the more unit that everybody kind of knows a lot more about. It's more commonly drilled, it's more commonly seen. We can see the bedrock, limestone bedrock in our buildings, so it's a fairly common unit. We call it the carbonate evaporite unit, or it's basically called the carbonate aquifer system. It's shown in light blue on top of that figure. Fairly thick deposit, and it forms kind of our most regionally and extensive aquifer that we have. You'll see in the following figures just exactly how big it really is. It mostly is composed of dolomite and limestone. That's, again, two different types of sort of the same type of rock, really, but it's an evaporite deposit, meaning that it was formed from a sea that came through there. That sea deposited these carbonate dolomite type deposits, and there's a lot of fossils. It's a very interesting sort of formation. Gradually dips off towards the center of the basin, gets further deeper the further you go west. And because it's so hard and fairly resistant to weathering, we tend to see it exposed at surface quite a bit. So the first figure there that has the little pocket knife in the bottom, that's in a ditch located near Stonewall, Manitoba, where the rock is really shallow to surface and is quarried. And the other photo there of the crevice, that's a crevice that's up near Clearwater Lake, up near the Paw. This is a great figure that we commonly use in a lot of our reports. It shows just exactly how aerially extensive the carbonate rock is in Manitoba and forms the aquifer. It basically runs through the entire interlake all the way up to the Paw. The darker shaded area there with all the arrows, that represents the area where the carbonate aquifer system is consisting mostly of all fresh water. So there is some mounding that tends to occur, and groundwater is recharged locally where it's shallow. So areas like Stonewall, where we tend to see the rock have very little cover over top, we get a lot of recharge coming in those areas just from rain and snowfall. Birds Hill is another feature. The Sandylands complex is another feature. As we go further, though, towards the west, particularly through the middle of Winnipeg, the southwestern portions of Winnipeg and kind of the western parts of the St. James area of Winnipeg, that's all naturally saline. And there's another saline freshwater boundary that we have to contend with. Basically, in the Winnipeg area, it tends to follow the rivers, except in the St. James area, it kind of trails off towards Lake Winnipeg. In those areas there, that's where the formation's naturally salty. And the change is a little bit more pronounced than what we see in the underlying Winnipeg formation. It's a pretty big unit. It's not as studied, or not studied a little bit more than the Winnipeg formation, but not a great amount more. The water quality in it tends to be more complicated, though, and it's mostly complicated due to the way it's recharged. So we tend to see areas where there's really fresh waters, really recent, like in around Steinbach, for example, we're recharged fairly closely here to the Sandylands feature. Whereas we get into Winnipeg, where the recharge areas tend to be fairly far away, and we see a lot of influences going on, so it's not quite as fresh as it is in other places. A lot of the recharge dynamics are also changed the way that the formation is fractured. There's no flow in limestone bedrock without any fractures or breaks. All the cracks, voids, joint sets, and karst features, that forms the basis of the aquifer. So without those fractures, joints, and voids and things like that, we really don't get any flow from it. And that's why the aquifer is so strong, yet it's also the case why we sometimes see dry holes in it. Within Winnipeg, the saline freshwater boundaries, it's always been my feeling that the rivers tend to create a little bit of hydraulic control for that, because west of the Red and south of the Assiniboine up to a point in St. James, the aquifer is quite saline in those areas. Was lying on top of the carbonate system is a series of shales, and these are a fairly thick sequence of shales, some minor amounts of sandstones, but not as much, and a little bit of coal or lignite. The primary unit that we're looking at in Manitoba that tends to form sort of a regional aquifer is the Swan River Formation, which is a very extensive formation, but the most one that we tend to talk about the most is around the Brandon area, which is the O'Donoghue Shale. It's shown in this figure here as two separate parts. Again, same with the limestone. We don't tend to get a lot of groundwater flow through shale. We tend to see it more coming through the fractures, cracks, and breaks in the shale. So it does mean that water quality and yields can be quite variable. Of course, lying on top of all of this bedrock is quite a fairly thick sequence of Quaternary or recent deposits. These are all deposits that are primarily glacial or lacustrine or sort of lake-type deposits where we've had former glacial lakes that have drained and we've been left with their deposits. So a lot of till. Till is mostly sands and gravels that are sort of held in a clay base. You don't tend to see a lot of aquifers in that, but we also see more deltas and beach deposits and things like that. So we can get a real smattering of geology here. Thicknesses can vary quite a bit, and we can end up with quite an interesting sort of set of circumstances. The biggest aquifers that we tend to have, there's three shown here. I would say that there's probably a fourth one in there as well, but the biggest one that's by far is locally known, I guess, as the Carberry Aquifer or the Assiniboine Delta Aquifer that lies sort of east of Brandon along the former delta of glacial Lake Agassiz. That one's a shallow sand deposit. It's heavily used for irrigation. Further to the west of Brandon, kind of south of Verdun, is the Oak Lake Aquifer. It's a fairly other large major feature. And then in the southeast here, in the yellow deposit, we have a very large feature called the Sandylands Complex, which is another massive deposit of sand and gravel that tends to lie upon on the surface, commonly developed for water supplies in places. The water supply in these things tends to be fairly strong, and the quality tends to be pretty good because it's pretty recent stuff. Fairly large capacity wells have been developed in each of those, mostly through screened water wells. Groundwater quality in Manitoba, we can have certainly all spectrums of it. We go back to the Winnipeg Formation here. If we were able to get down to the Winnipeg Formation, we would see, again, like 3 or 4 times seawater south of Brandon, very, very, very saline. Along the carbonate sequence, a lot of that dotted area that kind of lies along the Lake Manitoba, Lake Winnipegosis, Red Deer Point, Dawson Bay, all those things. That's where we tend to see a lot of saline conditions occurring there and a lot of natural saline springs occurring. So in Manitoba, even though we're fairly far away from oceans, we tend to see a lot of natural saline groundwater. This isn't something that we've caused, it's just something that the geology is giving us. So we do have to be prepared in Manitoba for saline conditions sometimes when we least expect it. Flowing wells. Not sure if a lot of people are familiar with flowing wells. It's something we have to deal with quite a lot. Flowing well is basically when the water level in the aquifer that you're working with is above grade. This can be fun sometimes, and at other times it can be a lot of problems. Down around the Emerson area, for example, right at the US-Canada border at the 75 highway, the static water level in the bedrock, limestone bedrock aquifer there, this is about anywhere from 30 to 40 feet above surface. Flowing wells can create a lot of problems for well completions. The center picture is a situation where a water well was attempted to be drilled and it basically wasn't able to be completed, so it was left flowing. In our winter conditions, they freeze. They can snap casings and cause other problems like that. So this is another picture of pulling an ice plug out of a flowing well, and as soon as that ice plug is released, can cause problems. So the figure on the left there on my screen is an old provincial report from the 1970s that shows the predominant flowing areas that are tending to show up. Along the western shore of Lake Winnipeg, we see it a lot in the interlake, sporadic places there. Um, and south in the southeast here in Steinbach, we tend to see a lot of flowing well areas. So these tend to be a bit of a problem. Um, Throughout the province, we have a fairly good network of stations that are recording water levels. These tend to be, they all tended to be started in the floodway project in the 1960s when we really didn't know a lot about groundwater levels. They started putting these stations in. So the first stations that we have dating back to say about 1962, and they tended to follow the course of the floodway, and then they were expanded upon after the floodway project was over. I think we have about 800 or so stations across the province. So we're certainly one of the better places around that has water levels available in the individual aquifers. So this is an example of some of the stations that we have. The top left one is a really interesting one. That one shows the relationship between the Winnipeg Formation sandstone and the overlying limestone. So the sandstone's in red and the limestone's in blue. We can see those formations. They tend to mimic each other very closely. In this case here, the lower formation is being pumped, and you can still see the effects of the pumping occurring in the overlying limestone formation. So there's a lot of interconnection between those formations naturally, and they do tend to mimic each other. This other figure here, it's a provincial figure that was produced sometime around the floodway expansion project. We've done some things in Manitoba that have interconnected the aquifer. So the floodway was an example where we did allow the Bedrock Aquifer to interconnect with the floodway channel, and there's been some leakage that has occurred. So that water in the low flow channel that you see the floodway is actually discharge occurring from the aquifer, and there's been some change in water levels because of that. So that's enough about the geology. We'll just talk mostly about how these geological issues and hydrogeological issues can cause concern for geothermal projects, and I guess for that matter, any deep excavation project in Winnipeg might see some of these issues as well. Geothermal projects tend to involve some form of drilling in the geology, and geothermal tends to be a bit of a crossover discipline. We see a lot of mechanical people that are looking at mechanical systems tend to get involved. So a lot of the times we tend to note that some of these geothermal systems maybe are not completed. There's no investigations done ahead of time into the geology so that we have a good understanding of that. And that can cause some problems. These investigations are really something that have to be done on every site before you undertake any sort of investigation to attempt to do a geothermal project, to avoid running into these problems that I'll talk about in a little bit more detail here. These investigations really need to be done by the proper personnel that are, say, licensed. There's geological sciences or geological engineering people that are licensed and able to do this. Some of these can be done through background, but a typical investigation really has to involve doing some test drilling in a lot of cases. Not always, but in a lot of cases. Some of the issues that we tend to see more commonly are just the basic geology, and the hydrogeology is somewhat missed. Geothermal technologies tend to involve either shallow or deep closed loops or things like that. What's interesting is that we often see these types of approaches used when we're going to do a deep closed loop system, for example, and the deep closed loop is going to run into very shallow bedrock conditions, and people didn't anticipate that. Or we see situations where they run into flowing conditions or bedrock conditions, like karstic conditions and things that can't be handled with the drilling techniques that they have. So this is just sort of a basic lack of a review of the geology and the hydrogeology before, and this applies to both closed loop and open loop systems. We have a database in the province, which is a really important place to get started, which is called the GW Drill software. It started in the 1960s when they required water well drillers to start submitting all their logs to the province. That database has grown now. I think there's over 100,000 water wells in there, and it's a great place to start any sort of investigations to see. This is a typical well log that we would get from the province that's contained in the GW drill database. It shows the different types of quaternary sands and gravels that you're running into in tills, and then it'll show you where the limestone bedrock starts. And then at the bottom of it, it'll show the results of any sort of pumping tests and things like that. Another important part of this is the concept of transmissivity. Transmissivity is basically how much water you can get through a piece of rock under a given head and a given pressure. And this plays a major role in selection of either closed or open loops, whether for grouting or flowing conditions or protection of those things, of nearby water supplies. That's another very important thing, is to have an understanding of how transmissive the rock is as well. This is a shot of a map series that was produced in the early 1980s by some authors that were doing some work at the University of Manitoba. The transmissive conditions, even across Winnipeg, changed dramatically. You can see in the downtown core here, we have a fairly, what we consider to be a fairly low number of 10,000 US gallons per day per foot. But then when we extend out towards the airport, we see that number has grown to almost 250,000. So the conditions across Winnipeg can change in a very short distance. And that again is mostly related to the fact that the aquifer there is fractured. We run into a lot of fractures, then you're going to get great yields and very transmissive rock. And sometimes we don't necessarily have those conditions. So having an understanding of the transmissivity is a really important thing particularly when you're working in Winnipeg. Groundwater flow is another thing that's very common. Parts of Winnipeg, we see the natural groundwater levels in the bedrock aquifer can fluctuate rapidly. We call it static water level, but it's really not static. We have areas of Winnipeg where, say, on its own, without any sort of influence, it can go up and down about 40 feet. Also, if you're near another pumping or injecting water well system, or maybe a domestic user or municipal user or industrial user, if there's quite a few in Winnipeg, levels can change very, very quickly. And again, those hydrograph stations can play a pretty major role in that. Winnipeg doesn't have any major heavy industrial pumping going on anymore, like it used to. When we had the meatpacking industries in St. Boniface, we saw an awful lot of heavy pumping going on in that area, and that tended to cause water levels to decline quite a bit. It gave people a bit of a false sense of security in that case, because when they stopped that pumping, there's been impacts as a result of that. So having an understanding of the groundwater levels in the area that you're working in is absolutely critical. Aquifer contamination and interconnection issues, I've lumped this up into one unit. I don't know if you remember when I was discussing the two bedrock aquifers that we have in Winnipeg, the Winnipeg Formation and the overlying Carbonate. They're overlying each other and they're protected by a thin layer of shale. The problem in Winnipeg in particular is, yes, part of the bedrock, the overlying bedrock, is naturally salty, but underneath all of Winnipeg, the Winnipeg Formation is naturally salty. And the level in the Winnipeg Formation, it tends to be a little higher at times in the Winnipeg area, in the Winnipeg Formation. So basically, if you drill all the way through the limestone in the Winnipeg area and you penetrate the shale and you get into the sandstone, you can contaminate the limestone bedrock with water from the sandstone that has a higher head pressure in it. And that has occurred actually in a number of cases, particularly in the downtown area, where people have inadvertently poked into the Winnipeg Formation and they've caused saltwater intrusion into the freshwater portion of the aquifer. So around the old CPR train station on Higgins, there used to be that Winnipeg, or I think it was Winnipeg or Manitoba cold storage. They were using groundwater there for mechanical refrigeration, and they drilled a number of wells there, and some of them did unfortunately encounter the sandstone, and they created a little bit of contamination with saline water in the bedrock there. Another well-known case is south of Winnipeg in the 1930s. Some industrial speculators tried to convince themselves that there was oil in the geology here, and they did an oil well test hole south of Winnipeg, and they drilled into the limestone and then drilled into the sandstone underneath, and they left it open hole, and that caused contamination in the area around Saint Germain. So working in these aquifers requires some pretty specialized knowledge on the proper grouting techniques that you have to deal with if you run into this to prevent the fluid movement that could occur between different parts of the borehole. Another common error that we tend to see, it's in our regulation, all of our domestic water wells have to be grouted in place with bentonite. That creates a seal between the casing and the geology that we drill. Bentonite does not hydrate in saline water at all. So the other techniques don't tend to work. So in order to cement or seal those zones, we have to run just plain old cement, basically, or like a mix of cement to try and create a seal there. And that requires that to prevent movement. Oftentimes penetrating the overburden, which in the Winnipeg area tends to be pretty clay rich. We tend to see a lot of septic systems in there, so we see a lot of bacterial problems resulting from septic stuff getting into the bedrock. Again, deep drilling near those boundaries also can be a bit problematic. The Winnipeg, or the south part of Winnipeg in the bedrock formation where the water quality is changing, drilling deeper into that formation to encounter the entire carbonate formation tends to cause water quality problems in the shallower parts of the formation. So you have to be very careful when working near those boundaries. Flowing well areas are very present in Manitoba. They can be encountered in areas where you least expect it sometimes. A lot of people tend to think of Manitoba as fairly flat, that we wouldn't have these types of problems, but naturally the conditions in some areas tend to flow. In Steinbach, for example, the bedrock aquifer that we have here flows. The water level at our office here is 10 or 15 feet above grade. This tends to cause a lot of problems if you're not expecting it. And this often involves another step of cementing surface casings in and things like that. But we have had a large number of situations where people have encountered these flowing conditions in shallow sands and gravels where they weren't expecting it. And if you're not expecting it, you can really create a problem for yourself in trying to deal with these issues later. The top figure there is a well we sealed that was left. It was a test hole that was left. Somebody didn't encounter it. I think the water level was 25 feet above grade, and it was flowing at about 3,000 or 4,000 gallons a minute at the time. So that can get to be a lot of water in a real hurry. Temperature and recirculative issues have been more prevalent in Winnipeg, where we tend to see a lot more use of the bedrock aquifer for industrial use. So that's where we're pumping from a well and running it through some sort of a heat exchanger process to cool it or heat it back up. And then we're re-injecting it back into another well nearby. Naturally in Winnipeg, we should see the water level or the water temperatures being between 6 and 8 degrees Celsius. These recirculating geothermal systems have raised that temperature in places. We've seen it as high as 15, 16 degrees Celsius. Somebody has told me as well, also it's sometimes the deeper foundations that tend to be piled down to the bedrock levels tend to create a little bit more heating of the bedrock. So we do tend to see a little bit higher levels. Sometimes those systems can recirculate as well, which results in the system not working. The big thing on that one is spacing between the wells and transmissivity, having an understanding of the transmissivity. This is a map of the thermal temperatures that were monitored in Winnipeg. We have a couple sort of north of where the Canada Packers and the Swiss plant was. There was some temperature problems there, again, related to their mechanical use of refrigeration. But we tend to see warmer temperatures of groundwaters in the downtown parts of Winnipeg, some of the more industrialized parts in the northwest part of the downtown core. So I would say by far and above, the most common problem that we tend to see on plumbing problems or the plumbing connections to water wells, that tends to be where we see a lot of problems. We have a couple ways that we can get pumps into wells and we can hook up wells. This is a residential style of connection where we drill a hole in the side of a casing and we can hang a smaller pump on something like this. This is called a snappy or a bulldog fitting. And these are very common in the residential world, but we do tend to see them in a lot of the smaller geothermal systems. If things tend to leak here, both inside the casing and outside of the casing, that tends to be where we see a lot of bacterial problems getting in. These types of connections are fairly universal, and as I say, if they're not done or not maintained properly, we tend to see a lot of issues here. This is more of what we would see on a larger system, where a fairly larger pump is used. This is a standard full spool pitless unit. These can be very expensive. They're usually dug in 8 feet below ground, and there's a spool on O-rings that fits inside of this that allows the water to go into a buried pipeline. These are usually something that we would tend to see more of on heavier industrial systems. This is a typical sort of pitless unit here. This is the spool of a pitless unit. You can see the O-ring surfaces here. I'm just going to go back to this. One section that we often see with water wells that tends to be a real problem is you can't completely seal a water well. You have to allow the well to vent. It's basically if you would take a pop bottle, for example, and stick a straw in it and then seal the straw into it and you try to suck the fluid out, the pop bottle will collapse in on itself because you need air to take the space that you've taken the water out. And it's the same principle with a water well. And you can see in this picture on the left, you can see that large sort of void right there. That is a pass-through that allows for the wires and stuff to go through it. It also allows air to get down into that well to allow that to take the space. So when you're pumping a water well, you have to make sure that you properly vent it. So in a lot of cases, you have to put in a secondary vent to a water well to be able to get air into it. And this is particularly problematic when you have flowing conditions. So you have flowing conditions and you put a vent or an air release or some way to get air into it, that's going to leak the water out. So in a lot of cases, if you don't have that, you have to bring a vent line in and you have to bring it high enough that it's not going to allow that flowing condition to get out. So flowing wells can be problematic for a hookup as well. These are some different styles of pitless units, but far and above, most of the problems we see on water wells tends to be in how they're hooked up and plumbed. Maintenance and connections to water wells and the plumbing. These are never going to be an easy situation. Sort of general maintenance and things like that. Often with a water well, it's out of sight, so it's out of mind, and we tend to see a lot of things that get forgotten about and missed. So these tend to cause problems with heating and cooling systems as well. Some of these pictures, that one up in the top right, this one right here, this is a 5 horsepower pump that was set in 5 or 6 inch PVC. They set up the plumbing system so the variable frequency controller for this motor basically could send power down to the pump without there being a valve that was opened. So what happened is the pump deadheaded. The pump continued to run. There was no water getting past the motor to cool it. So the motor basically fell off the drop pipe and it melted itself into the casing. And the sad part about this is the 3rd pump that was in this well. They had lost a couple others in this before they called someone to come and try and find out what was wrong with the well. It was actually the controller that was causing the problems. This one here on the bottom, right here, this is a snappy adapter that has been cut into the side of a municipal or a domestic style of geothermal system. The system was just absolutely riddled with bacteria, and they couldn't understand why. The snappy connection right here, you can see this black trail that's leading down here. This is where the bacteria was getting into this water well, and it had a problem of over 100 coliform units. They couldn't figure out why it was so riddled with bacteria. This picture up here looks like a bomb has gone off in this well here. This is a 13-inch diameter submersible pump that the drop pipe failed due to lack of maintenance, and the drop pipe fell 150 feet into the bottom of the well and exploded the screen. So maintenance is a huge issue for these things. Water wells have to be maintained. They're so commonly overlooked because it does require a little bit of specialty work or camera work sometimes to get in there. You do have to pull these things apart every so many years, even if things are going well, to take a look at them to see what type of problems could be avoided. So water well maintenance is something that's not commonly done, and that does create a bit of a problem for these systems. From a regulatory point of view, we have a number of acts and regulations that we do have to follow. So there is a Groundwater and Water Well Act that deals with the proper construction of water wells in the province. That one, there's some changes that are coming on that act. We also have a section that we follow under the Water Rights Act. So anytime that we use groundwater, specifically from a well system, we have to apply under the licensing section of the Water Use and Environment Department, called a groundwater exploration permit. And that is required before we do any sort of investigations into groundwater. It involves the use of groundwater, but it also involves the use of it for not only for consumption, but they define the use as also taking or removing energy from that water as well. So recommendations, the geology in Manitoba is complicated enough that you can get yourself in some real trouble very quickly if you have not investigated the geology ahead of time. So in checking these things and having a good thorough understanding of these things, flow rates, water levels, flowing conditions, the type of geology you're going to run into, these things all can be determined ahead of time. And the protection of our groundwater resources is really important that we carry through with those types of investigations first. We like to promote the use of geothermal energy, but it certainly should come with the promotion of good aquifer protection and management as well. So that's all I had. So I can take any questions here in the last 15 minutes, and I'll do my best to answer them.
All right. Well, thanks so much for all of that incredible information. Things you think about, but then you realize how much you haven't thought about when you hear from somebody like yourself. So thanks for that, Jeff. Just a few questions so far here in the chat. Feel free to either raise your hands, folks, or drop your question into the chat and we'll get those answered. So the first question's coming in. It says, have you seen any attempts to compare the geology of southern Manitoba and the city of Winnipeg with indoor radon levels?
I'm not really a specialist in radon, but the geology that would tend to promote that type of condition is present here with the clays that we tend to have. So around Winnipeg, it's a sort of like a lacustrine lake bottom clay because we had quite a post-glacial lake here. So we have a lot of this very slow deposition of silts and clays and things, and that tends to be the places where we see radon. So I'm not surprised whenever I hear people mentioning that they get radon levels in Winnipeg, but it's not a specialty of mine to look at that. So
very fair. All right. The next one is just asking about what species invasions happened due to water extraction, silica sand mining, etc.
That's a tough question. I'm not sure I totally understand the species things. We have interconnection of the two aquifers that has been fairly prevalent, mostly in, I would say, in the Steinbach area. It's areas where both the limestone and the underlying sandstone aquifers have been commonly drilled for water supplies because they're both fresh. And there was a little bit of an old tale in this area that the sandstone water in Steinbach was quite a bit softer. So it would be very common to actually drill through both formations and allow the two formations to mix, and you ended up getting a softer water quality out of it. We have about 10,000 wells that we know about that have been drilled through both of those formations. And it was something that we always tried to stop happening. We didn't really know enough about the changes in the 1930s to stop it. But by the 1970s and 80s, we were actively pursuing to get it stopped. And finally, we do have regulation now in Manitoba, which does prevent you from interconnecting to different formations and blending the water quality. And that was a key problem, obviously, for the Silica project, was the interconnection of the two formations. I'm not sure whether they were able to ever come to any terms with whether they could do that successfully or not. But the two interconnecting problems were a real problem. So.
If I could clarify, please.
Oh yeah, jump in.
Thanks. Yeah, I was wondering if that by species invasion I mean did destructive non-indigenous aquatic invertebrates or destructive non-indigenous plants, for example, get around more easily because of human activities?
We haven't really seen anything like that in groundwater in Manitoba that I'm aware of, but the mixing of the two formations has caused water quality changes. But like we always say in groundwater problems don't tend to come up like all of a sudden. They tend to develop very, very slowly, and like they're typical with any geological problem, they can take 20 or 30 years to develop. So
Makes sense. All right, so next question. Into what formation would you drill for geothermal installations in Winnipeg?
We have had no success at all in doing test work or anything with well-to-well heating and cooling systems for industrial or anything in any of the screened units or any of the unconsolidated geologies. Sand and gravel, like screened water wells, we don't tend to see a lot of great results in that. So the formation that we tend to work in the most often is the bedrock formation. So most of the common well-to-well systems tend to involve something to do with the bedrock. So.
Okay, great. Can you provide references for Winnipeg wells and local geology and hydrology?
References, like I'm not sure what sort of references, like technical references or
your maps that showed boreholes and so on, and the reports, the well reports.
Oh yeah,
So
just I can, my email is I can share you my email and you can certainly contact me and I can share you references for that. Yeah.
Okay, thanks.
Incredible. Sharing is caring, as they say. All right, next question is coming in. Can open loop geothermal systems cause washout and cause structural issues as the system continues to operate?
I don't know that necessarily that would be related to just specifically water wells or to geothermal systems, but obviously if one of the more common problems, 9 times out of 10, I would say when we get called to a problem to deal with a water well, it tends to be the hookup. It tends to be the pitless unit or how the pump has been installed in the well. Those units, up until about maybe 5 or 10 years ago, there's really only one manufacturer that was making them, and they were building them all out of galvanized products. So they didn't tend to last very long in Winnipeg's pretty aggressive water quality in places. So when they failed, you tend to see quite a washout. You tend to see some pretty big holes in casings, and yeah, I've seen it wash out a lot of things and cause some damage to all sorts of stuff. So yeah, maintaining those systems tends to be really important for that. So.
Oh yeah, maintenance. We all know maintenance is easier than coming back from bed. Okay, so next question. What is the first step in exploring feasibility of a ground source district heating system? We're talking 50 to 60 homes here.
District systems, you have to obviously understand the type of geology you're in first to make sure that's something that you can look at. There has been some district systems put in Winnipeg. The geothermal aspect has to be looked at first, and there's not always necessarily a solution that's going to work for every situation. It has to be something that you have to look at the available property that you have. If the wells can be accessed in the future to get serviced, if they're going to be accessed through private property or things that might be a bit problematic. A lot of the places where we look at an individual house, like an individual lot or a small city lot, these tend to be very problematic. Our drilling tends to make a lot of mess. don't necessarily like to see that sort of thing happening. And it tends to cause some problems. So, oh, somebody's saying it's in Brandon. Yeah, so there's no real major mapped aquifers in Brandon that are bedrock aquifers. So you're looking at pretty much closed loop. And if you're looking at closed loop, then you should do a bit of an investigation first, just to see what type of geology you're going to be working in. So.
Okay, thank you. And thanks for the clarification on location there. Okay, so coming in, what are the typical depths you see for drilling for closed and open loops for geothermal energy systems in southern Manitoba?
That's a tough question because there is no real typical depths. Say we have areas of southern Manitoba where the bedrock is exposed in the ditches. We have areas of southern Manitoba not far from Winnipeg where the bedrock's 150 feet below grade. So it really can vary quite a bit. Water wells in the bedrock sequence or the limestone bedrock or carbonate bedrock sequence, they also can vary quite a bit as well. The only way you get any flow through those wells is through capturing those fractures. And if you run into good fractures, then you've had a good day. And sometimes you don't necessarily have a good day. So.
Ain't that the truth? So somebody wants to know about Southwest Winnipeg. Same question. I assume that's the first step for exploring the district systems, or no? Or were we
Yeah.
looking at? Oh no, this is the typical depth. Sorry.
So Southwest Winnipeg, if we were asked to look at something in Southwest Winnipeg, the first place I would go would be those geological engineering maps for Winnipeg that were published in the 80s. Western parts of Winnipeg, we tend to see the till coming to be very shallow to surface. The bedrock does come up in that area quite a bit, but we do have also a bit of a bedrock channel that's been cut through there, and there's been some infilling and stuff going on. So would depend on where you were, but I would look at those maps first to get a handle on sort of what depths you would expect the bedrock at. So.
All right, thank you. Thank you so much. Kurt, I see your hand. If you want to unmute and ask your question, that'd be great. Thank you.
Good, thanks. Thanks, Jeff. And thanks, Laura. You've given us justifiable cause for concern, Jeff, to caution when it comes to anything that we do, and you've suggested a couple of potential fixes. You talked about maybe having to pour concrete or cement to make a seal. Is there anything that's irreversible? Like as you go into this, you rightfully got to take care of the aquifer, make sure you don't contaminate the aquifer or mix the different layers, stuff like that. Do you have strategies for, because a lot of times as you say, it's not really known until you drill exactly what you're going to find. And so is there anything that might be, that's it, you've done it and you can't fix it?
There's a good answer to that and a bad answer to that. So a lot of problems in groundwater hydrogeology tend to take a long time to develop. And they often give you a lot of warnings that they're coming. So a lot of the times that we suggest that these systems, fairly heavy monitoring, a lot of people would tend to complain about that because, well, we're just getting the same thing over and over again. But groundwater monitoring tends to show you where problems are starting to develop. And if you ignore the warning signs with that, it often takes many years to see something like that develop. You can get yourself into a situation where it's not necessarily something that you can go and fix. Like we have saline water that's leaking from the Winnipeg Formation into the overlying limestone bedrock aquifer in downtown Winnipeg, somewhere near the area, the former Manitoba cold storage on Higgins. Those wells were drilled in the 1920s. Nobody really knows where they are. How they were sealed, we don't really know. The chances of us being able to find those would be very, very difficult. And, to the extent of how quickly you could clean up something like that, you tend to create a problem that is not something that's going to go away. A lot of the times too, we've done things deliberately or unintentionally sometimes where we have permanently modified the effect of our aquifer. Winnipeg is a classic example. I mean, the floodway did create some water level impact. in the aquifer. And I think in the 1960s, they went into that knowing that. Can we deal with the impact to the aquifers, or would we rather have the floods? Is there another alternative? I mean, I don't really know, but there's not always a way to solve these problems, but the monitoring sometimes can give you an indication that there is something that's coming. So.
Thank you. Next question. How durable are the bentonite and concrete grouting / seals? What is their life expectancy before they start to fail? Decades? Centuries? What?
I think that's important to know that, like, particularly where we have saline conditions, for example, the seals that naturally are there are not perfect either. So, we often go to great lengths sometimes to try and stop flowing conditions, and that's everyone thinks it's a good thing to do, and it is. In some cases, we find that when we've sealed them, it's popped out somewhere on its own. Springs are a natural part of our environment. We're not creating perfect seals all the time, even in the natural environment. We have a lot of springs in Manitoba. Steinbach is well, it's a German word for stony brook, but there was a spring there that originally started, and that forms part of the town. You can't necessarily make sure that these things are going to be something that's never going to fail, but the cement that we would use, for example, to seal between the Winnipeg Formation, the overlying bedrock, is going to be a lot more perfect than the shale that naturally exists. I have pieces of the shale here. I mean, it's far from perfect, but the cement is certainly as good as we were able to do in there. It certainly is better than what is naturally there. So.
Okay, thank you. What additional mapping or monitoring would you recommend that the provincial government undertake to encourage increased adoption of geothermal energy systems in Winnipeg and elsewhere in southern Manitoba?
Yeah, that's a good question. Prior to about 19, like, our science and hydrogeology is relatively new. The basics of our math that we used to look at groundwater sort of performance from a water well really started in the 1930s. So we're relatively new on this stuff. Manitoba was actually at the cutting edge of that. We started our groundwater department in the 1950s. I think it was 1958 we had our first hydrogeologist. We were 10 years ahead of other provinces in that. Our monitoring network that we have here is fantastic. Our department used to be really, really large. It's not quite as large anymore. We have a really great monitoring system here. We are kind of losing pieces of it sometimes over time, but I think in the overall, we're doing fairly well from that. What's important to note on a groundwater system like this, and why the province doesn't get overly concerned about it, if you have a pumping and recirculating well pair on your industrial yard site, and you're in the middle of downtown Winnipeg, which tends to be serviced by municipal water supply, you're only affecting yourself. And if it fails, the only person that tends to know about it is you. So they don't tend to get overly concerned about that. The first person that tends to see the causes of these would be the system itself. So going back to that whole comment on monitoring, though, I mean, if you're not monitoring your incoming and outgoing temperatures, then you're not going to have an understanding on how quickly your problem is going to start until the system just doesn't work anymore. So the province isn't going to be able to save you on that. So.
Okay, so is it possible to drill geothermal wells in the areas of northern Manitoba, thinking Flin Flon, Thompson, First Nation communities, etc.?
Yeah, I mean, I'm not by any means an expert in this, but what we have seen in those types of situations is people have done it. But as we get further to the north there, we start running into that situation where we're seeing sort of discontinuous permafrost. And we tend to see the rock temperatures getting cooler and cooler down to a certain depth. So it's very important that the investigation would identify those things ahead of time so that you're not getting into a situation where it's just not going to work. We had somebody attempt, I think one in the Paw one time, and I mean, we expect 6.7 degrees Celsius or something like that in downtown Winnipeg, or in something similar in Steinbach here. Up in the Paw, I think the average groundwater temperature is about 3 degrees Celsius. So the province allows you to take 5 degrees Celsius out, so you're not far away from freezing that water. So